We were about to be live. All right, we are streaming.
Cool. So Christy, are you going to give an intro first, or should we just start?
Yeah, feel free to just go ahead. Yep.
Okay. Well, thank you for joining this LFDT, Linux Foundation Decentralized Trust meetup for Smoot. This is the second meetup we have. And this meetup is more about the technology side of it. We have made great progress with Smoot, and we have some applications that we can demonstrate to you. And then we also want to walk through the code base so that people who are interested in quad-chain applications can build easily a quick and beautiful quad-chain applications. And today, me, Weijia Zhang from OneChain, and the Meredith from Adera are going to give you this presentation. If you have any questions, please feel free to kind of send in a chat or raise a hand or do whatever you can do to let us know you have some questions. So we're going to proceed. And in this presentation, we're going to show the presentation. We also have GitHub walkthrough and also have Remix compilation, or also have GUI. So we may need to switch screens here and there. Yeah. And let us know if you have any visual difficulty seeing the slides. So let's move on. Yeah, today's content, we have three parts for today's presentation. The first part is Smoot, a quick overview. And I think 6 months ago, we had the first meetup, we have a overview, but some of you may not be there, and some of you may forget the content already, and we have made great progress. So we're going to give a quick overview, and then do some Smoot update about the work we have done in these 6 months. And then we also want to have a technical deep dive and demonstrations, and then walk through the code and then the demonstration as well. So part one, a Smoot quick overview. Okay, and the first question, of course, is what is Smoot and what does Smoot do? So Smoot is an open source project for interoperability. What it means is that its intention or its mission is to connect different blockchains effectively. Okay, in the past, we always believed that only one single chain will survive, and the other chains are going to fade away. But it turned out that many chains, hundreds, thousands of chains are going to coexist. And now the question is, how do we connect them? Just like internet connecting PCs, we need to connect blockchains through interoperability. So the mission of this Smoot open source project is to connect different blockchains. And then we have three things for this connectivity. One is to facilitate the transfer of assets cross-chain, which means that when you have an asset in Bitcoin blockchain, you can lock the asset and transfer the asset to another blockchain and use it in another blockchain for other applications and in other formats. And the second thing is that we want to be able to allow data in one blockchain to be accessible to other blockchains. If you have some data residing in one blockchain, there's no need for that piece of data to be copied to every blockchain and use it and stored and use it in other blockchain. That costs a lot of storage. And what we want to do is that you have this quad-chain data transfer or the metadata transfer. You can let the data reside on one blockchain and make it accessible to all the other blockchains through interoperability. And then the third one is enabling the cross-chain function calls. And that will be like you have a smart contract in one blockchain, and then you can execute that smart contract from a remote blockchain, a separate blockchain. And that will be almost like a remote procedure call for computers. So these are the three things: asset transfer, data transfer, and then remote function call, almost like a command transfer. And one of the unique things about Smoot is that This is an open source project, and it is in compliance with EEA Enterprise Ethereum Alliance Interoperability Specification. And we released this interoperability specification last year, and Smoot is one of the open source implementations for this EEA interoperability specification. And the thing that we want to do is that you should be able to use some standard interfaces and write a smart contract once and apply that smart contract in any blockchain. Okay, then just a little bit background. Why did we choose the name of Smoot as the project name? Okay, we want this project to be open source. We know that. So initially we named the project as Open Bridge. This is because bridging blockchains, but that name has been used, and then we use letters and choose different names, but they have been all used. So we chose this Smoot because there's a history with Smoot. This is a person's name, and this guy back in 1958, he used his body to measure the length of Harbour Bridge over the Charles River in Cambridge. And then what's interesting is that Smoot actually is becoming a measurement unit for bridges. Okay, so the one Smoot is equal to 5 feet 7 inches. So then we think this is a very good name related to bridges. So we choose this name. Nobody was using this name, so we are good with copyright and everything. So that's good. Have a good project name. And then a little bit about the EA. EA is a open standard organization that produce standards, and we produce this EA distributed ledger technology interoperability technical specification, and this was released back in September 2024, and there are a lot of interfaces defined, and it's a very lengthy specification. But when you you can simplify it to just a simple set of APIs that you can implement. And Smoot is an open source implementation of this EA interoperability specifications. And the use cases, okay, I mentioned a little bit on that already in the overview. First, you want to do the cross-chain asset transfer, and then do the data transfer, and then also the application, cross-chain applications as well. And then we also want to support the public to public and public to private blockchains. And also we want to do L1 and L2s. It's you can support all the different kinds of topology of blockchain network. Yeah, architecture. We classify into 3 layers. Okay, so let me show you the next picture, which is more. Oh yeah, this is more visual. Okay, so there are 3 layers. The first, let's look at of course, the top layer is the user. This is just the application, and then after user use their wallet to access the application, this the application layer. They can do data, asset, and command transfer. This is the application layer. This is what we normally call decentralized application (DApp). But this DApp is not just DApp on a single chain. It's a DApp that's cross-chain. So this layer is the cross-chain applications. And the second layer are smart contracts residing on each blockchain. And this blockchain could be private blockchain, public blockchain, EVM blockchain, or not even EVM blockchain, Cardano, Sweet, and then anything, Octo, heterogeneous blockchain other than EVM. So this is the smart contract layer. And then the layer will be the multi-sig, MPC, GKP, like-kind, or hybrid method. And then these are the kind of topology of these infrastructure we have. And then if you classify them into 3 layers, there will be an application layer, command layer, and then messaging layer. So these will be 3 layers. And then we created a repository already, and then we kind of modularize it, and then just separate the relayer, separate the services, separate the smart contract, and then decentralize application. I'm going to walk through this in the after the demonstration so that you can have a clear hands-on picture of our repository. Yeah, so this is I just finished the overview of a Smoot project, and you can read a lot of these contents through the LFDD publications and then the previous meetup as well. Now, part 2 is about Smoot update. It has been a couple of months already since our last meetup. And when we present this Smoot project to the FFDT, we mentioned that we are going to have 3 phases. The first phase is we want to migrate the one-chain code. This open source code was originally produced by OneChain, which is a bridge project for blockchains. We want to migrate the OneChain's bridging code to Smoot. We completed that already. So that's phase 1 completed. And phase 2, we mentioned to the LFDT that we want to kind of consolidate interoperability projects. So we mentioned that we want to combine Project Smoot and the Harmonia lab, which is another effort in interoperability space in LFDT. At that time, we had the vision that we want to merge them. And it just happened that because all the things happened, and in phase 2, we were able to merge these two efforts. This is great, and this merger has been very, very successful. And today we have both me and then Mary-Liz from Harmonia Lab to present this together, and she's going to mention about Harmonia a little bit also after this slide. And then third phase is that we want to do cross-chain application development. And this, we have made great progress on that already. We actually implemented and developed a decentralized application for crossing this EIP 3643 token. And this is an extension of ERC20 token. And today I'm going to show you that example and also the code base for that. Yeah, so there's more detail. The phase 1 completed. It just migrates one-chain implementation to LFDD repository, design code base to be vendor agnostic, so that nobody needs to depend on any vendor's library or proprietary technology. Enable modular component addition by contributors, so that anyone who wants to contribute to it can just create directory and then submit pull requests that do whatever they want to do. And once it's approved by maintainer, the code can be accepted to the code base. And then open source code base designed for community contributions. So this is designed for open source community. Yeah, and then the phase 2 convergence. I want to consolidate the interoperability projects. So we are very lucky, or we also thank the Harmonia team that we were able to merge the Harmonia project effort, and then we become one. And then we also want to do a little bit more collaboration with Cacti project. And this, we are researching it. We are working with the Cacti team, with Rama and other people in Cacti team. Yeah, and then I want to transfer to Mary-Liz to mention more about the Harmonia. Mary-Liz, you want to take it on? Yeah.
Yes, hello, hi. So what is Harmonia? Harmonia is an open source lab that started. We aimed at capturing ideas and requirements so that we can start designing services needed for interoperability between blockchain networks as they were used by regulated financial institutions. So at that moment, securities was sitting on a R3 Corda ledger and cash was sitting on an Ethereum ledger. So it was sort of born out of necessity. We needed a place where we could share code, white papers, documentation, etc. So Harmonia was created by Diodara Labs and some contributors from R3. If you can go to the next slide. So what came out of this collaboration was two models. Adara proposed sort of a trustless relay model, where one identity on one network will only trust an identity on another network if it can provide cryptographic proof. There was no trusted intermediary, where R3 sort of thought this was very entangled, and they proposed more a vicarious trust model, where one entity on one network will trust their counter ego on another network. And that still means that there is a legally accountable intermediary. But Corda has sort of a built-in legal contractual framework that made their arguments very viable. For us to reach sort of a common point here meant that we needed to upgrade to Corda 5, which was at that moment we were very much driven by our use cases, which was HQLX wanting to go into production, and so we didn't collaborate any further. Adara sort of stuck to the EEA compliant proofs, so we contributed sort of your event-based block header proofs for Ethereum, and then for Corda, we tried to do something similar, and we came up with a transaction-based Merkle proof, which is then signed by Corda notaries and participants. Sort of what came out of Harmonia. Then what was merged? So what could we bring over was sort of Solidity verifying contracts. There's the block header proofs from Ethereum, and then the very expensive Corda multi-Merkle proofs. And there's been much improvements even after that could be done. It's like we have a pre-compile since the end of last year for the SEC R1 curve. So a lot of that code can even be taken out. There is sort of currently too much code, but there's some good Solidity contracts that can come over. And then the relaying services. Proof generators can then be taken out here and merged in properly. Not so much the services as the banks and the financial institutions, and like in Harmonia when we were going this way and that way. There's a lot of settlement instructions and things in there that's not necessarily useful for something as general as Smoot. So that's why I say like relaying services will most probably be replaced by Smoot services. And then how can we extend it? Adara went further with our interoperability. Fin peer-to-peer is a nearer solution of having lots of a network of routers that can take receipts of blockchain networks, and then you sort of and sign it. And you trust this additional layer of routers, the Onera Fin peer-to-peer network. And out of that, we built another proof, a multi-signature based proof, still EEA compliant. And it used an Ethereum standard, the EIP 712, for hashing and for signing. So we were still very Ethereum standard. And this can be contributed back into Smoot because it was going to go into Harmonia anyway. So this is something that we can still give back into the project.
Yeah, well, thank you, man. This is great. Yeah, there's still some work that need to be done in terms of consolidating the layers and make those relay modules to be more generic. And I think this is a beautiful research. When I look at that, the block had the proof and then all those Merkle trees, it's very beautiful. I think there are a lot of work that can be leveraged over there. So if you are interested in looking at the transactional proof or block header proof, and then also interested in Corda related ecosystems as well. This is the place to contribute. Well, thank you, Mary-Liz. That's well, if you have any question, we can discuss it later. But let's move on to phase 3 adoption. Any open source project need to be adopted and need to be used, and we have been thinking about applications right from the beginning. So several things I want to mention here. The first thing is that we want to build enterprise solutions based on Smoot framework. and we try to put in this enterprise quality code to the system, and then develop end-to-end use cases, including GUI components, because sometimes some of the open source projects do not have GUI and just have some APIs. We want to have end-to-end, including the GUI, at least as an example, so that people can build a kind of good-looking applications. And then we want developers to leverage a Smoot source code easily. And then we want the infrastructure providers to enable that third-party app development. What I mean by this is that you can, as a third party, you can take the whole Smoot code base and you can build the framework component, and then you can let your development community to build the dApp on top of your framework. So we want to enable that as well. So we make some progress, and today I'm going to show you some of the applications that have been developed. And of course, the first thing I want to show is the ERC3643 token cross-chain demonstration. So let me switch the screen to a GUI page. Yeah. So this is a GUI page for ERC3643 token transfer cross-chain. And ERC, for those of you who are not familiar with ERC3643, just a little bit information here. What we all know about ERC20 token, and that is a non-fungible token, and it's transferable. It doesn't have any compliance. It doesn't have checking for anybody, anything, and then any user can transfer that token to any other user. But this ERC3643 is a compliance token. You need to have checking about the user. You need to have on-chain ID, and then you need to be verified. The receiver need to be verified in order to receive the token. So it's a compliance token. So this bridge allows the ERC3643 token to be transferred cross-chain. Okay, just do a simple demonstration here. You can the main screen here, you can asset bridge, and then there's a form chain, and you can choose a chain, the source chain. You can choose Ethereum, and you can choose a asset. Okay, we just have a markup token. This ERC3643 token, SYMTN, and they want to transfer this token to another chain, which is Polygon, which is marked as Polygon, and the same type of token. And then we just want to say I have 6 left, so I'm going to transfer maybe 1. Well, just transfer 1, and then click next. Okay, just confirm that you should not send it to exchange address. If you change it to exchange address, then that asset get lost. Because you need to own the private key of that the target address. So you just have a warning, and then just confirm. And then this shows you that you want to transfer 1 token from this Ethereum chain to Polygon chain, and then you just confirm it. Yeah, and then you just you pop up a MetaMask, and you just confirm, sign it with MetaMask. Yeah, and then it just start locking the original asset in the source chain, and then mint it on the target chain. And this is ERC3643. It's not ERC20. And you can see that screen is going on. And then after maybe I don't know how long it takes, maybe 1 or 2 minutes, it's going to be successful. And then you can also go to history to look at. Okay, and then for time reason, we can come back to this after it's completed. Let me see. Let's move on then. Oh, it's completed. Okay, it's completed now. That's good. So I want to switch the screen back to the. Yeah. Okay, so actually I can show you a little bit more. So once it's completed, you can go to the history here. You can see that there's one token today, actually 15. Yeah, today this token has been transferred from Ethereum blockchain to Polygon blockchain. So it's successful, and this is fully built with Smoot framework. I got some chat message here. Let me see if there's a question. Okay, yeah. So if you have any question about this demonstration, please feel free to send a message. But I think the whole demonstration is perfect. So and also the time is good. So we have that demonstration shown, and it shows that you can easily transfer a compliance token from one EVM blockchain to another EVM blockchain. And let me go back to the presentation here. So we did the token blockchain demo, and then we want to do a little bit ERC 3643 overview and smart contract so that you can see how this happened. So let's go for it. And then we're going to describe the token bridge and smart contract as well, and then how to build a blockchain application. Okay, I did this one. I did the demonstration for transferring that token, which is successful. And these were the screenshots that I took in case that demo does not work. Okay, but it worked perfectly. So I don't need these slides. I'm going to skip these slides. Yeah, I don't need these. That's good. Yeah. And then now the next question is, okay, how do you kind of create a ERC 3643 token? Okay, just let's mention about a little bit about this token, this kind of token. So it's called a T-Rex protocol token. It's the token for T-Rex means that token for regulated exchanges. Okay, and this is a standard produced by this protocol project team. And then the difference between ERC20 and ERC 3643 is that it's an 3643 is an extension of ERC20, and it has additional 10 plus more functions and events defined for this token, basically for implementing the compliance. Have the identity check, have the issuer check, and then have the guardrail to make sure that the token follows some rules in compliance. Okay, and then this is yeah, and then there's some rules implemented. And if you compare the ERC20, which is what you can label that as a utility token or security token, there's the purpose difference is that this ERC20 utility is made for usage, and then the security for investment, and then regulation is almost non-existent. You can send from user A to user B, no problem, no checking on that. And then this one, okay, security token need to have some checkings, and life cycle simple, and then this the others are more complex. And then the no constraints for ERC20, and then there are complex constraints for the security. Okay, so for ERC20 token, you can transfer from user 1 to user 2 without any checking. So you just need to have a ERC20 token smart contracts to do that. And then for this 3643, you need to have a check. You initiate once the smart contract receive the tokens, initiate the checking, and then the validators, both on chain and off chain, will process the checking of the identity and then return the status. If the status is good, you do the transfer. If it's not good, you should not do the transfer. So it's kind of adding additional layer for compliances. Yeah, and then this specification define many new events and many new functions. I'm not going to walk through these here. Okay, so yeah, these I'm going to skip these definitions. You can just go through the specification of ERC 3643 to see how these are defined. Okay, and of course there are some challenges for cross chain as well, because the compliance can change on one single chain, and how do you transfer that change into another chain? So there are some challenges on that. And this is the references for the ERC 3643 specification. Yeah, and then I'm going to show you how this ERC 3643 token have been kind of compiled, and yeah, and then just let me see. Yeah, there's here you can easily use a Remix to compile ERC 3643 token. You can just go to I just pulled out the GitHub, and then the GitHub code into Remix. Remix, for those who are not familiar with Remix tool, this is a tool, IDE for Solidity compilation and deployment for testing. And I just use this to show that how easy it is to compile token and then deploy as well. So if you pull down the GitHub repository, you're going to see there are some tokens here. There's a token.solidity, and this is the one that actually has the token written, and you can just define the token here, just like ERC. Oh, this is the document. I'm going to reload it. Oh, once I reloaded, that thing goes away. But you can easily do a GitHub clone. Let me see if I can do it here. Yeah, let me see if you can go on the fly here. So I want to clone this one. There's an implementation by one chain about this ERC 3643. I want to clone this GitHub onto the Remix compiler, and once it pulls down, and you can see there's a smart contract here, and then you can see that there are tokens here, and you open it up, there's a token file here, and this is the one that actually is the implementation of ERC 3643. So it's very easy. Just create a workspace and then pull down the Solidity code in the GitHub, and then you can start compiling these codes. Okay, so this is for developers. If you want to try it out and just pull it down, and then you can see that all the ERC 3643 token events and functions have been implemented here. And you can have this one here, and if you want, you can compile this code. Yeah, I think it's good. And then you can deploy it as well, and for testing purpose. Oh, it's so big that it to 4%. Yeah, I think it's deployed onto the local machine here. Yeah, this is the one. Yeah. So it's deployed onto the local EVM here. And then you can see all these ERC 3643 functions are here already. This is the compiled version deployed on the local EVM here. So you can easily see that ERC 3643 token can be compiled, deployed, and then can be used for cross-chain. Now I'm going to talk about how do you make it cross-chain. Okay, I'm going to stop sharing this one. This is a compilation and deployment of ERC3643 token. And the next step is, how do I build an application that leverages this token across different blockchains? So let me go to this one. Yeah, build a quad-chain dApp with Smoot. Okay, Smoot is a quad-chain project. And what needs to be done, okay, and this is the location of our source code. What needs to be done when you do a quad-chain bridging, you need to write smart contract on the source chain, you need to write smart contract on the target chain, and you need to specify your application saying what you want to do with the source chain activity and what you want to do to trigger events on the target chain and then operate on the target chain. So in order to build a quad-chain application, several things you want to do, okay, especially when using Smoot. First, you need to have a compiler such as Remix and the deployment tool. Remix is for you to write smart contract, compile smart contract, and deployment tool is like a more secure way of deploying your smart contract, the bytecode, into the target blockchain, different blockchains. And then you need to identify chains to support and get tokens for these chains. Okay, if you want to deploy, you want to build an application for Ethereum blockchain and Polygon blockchain, that like what we just did, you need to have tokens for these chains, and you need to pay the transaction fee for that. Okay, and you also need to have chain ID for these chains, and chain IDs are the ones that we use to identify different blockchains. And then you need to understand the Smoot quad-chain messaging protocol. You need to understand some of the API we use, some of the function call we use, and some of the hierarchy, the libraries we have. And we can look at the code easily after this overview of Smoot code base. And then you need to, after that, you can easily, okay, these are just understanding and getting the logistic work. And then you need to extend your smart contract on top of Smoot framework. Smoot framework has a lot of smart contract written already. When you have your decentralized application, the code that you need to write is minimum. You can, even for this ERC 3643 quad-chain, you can only write like 50 lines of code or 100 lines of code. You can have that quad-chain function already, because all the others have been implemented by a Smoot framework already. And then this is a tougher job, is that you need to build the GUI and the web page to talk to smart contract. Okay, so this is up to the dApp. This is the dApp layer, but we have some good example. Check into the repository already, so you can write that GUI code based on at least you have some sample code to refer to when building a GUI. And then you need to package and deploy your quad-chain decentralized applications. So this is the whole flow, and the actual core work, developer work is kind of minimum. It's just for example, you just need to extend your smart contract on top of Smoot framework, and you also need to build a GUI for that. Yeah, and this is just this is just a text form of what I described to you. Yeah, and then let me go through the GitHub and then describe to you the Smoot GitHub for this application, and also the general structure as well. Yeah, so this is the GitHub for Smoot project, and you can see that there are many things that's implemented here already, added to here already, and the smart contract is in this directory, and many times you just need to write the smart contract for your application, and yeah, you can like smart contract classify into different chains. And for example, you can look at the Ethereum chain and the smart contract here. There are token messaging bridge contract. These have been done by Smoot's team. And if you want to contribute, you can contribute that as well. And this token contract is the one that's implemented for like ERC 3643, ERC 20, NFT smart contracts. So these are application specific token smart contracts. So you can have these smart contracts. Yeah, and then there's some apps and the token here. My token 3643, token home, token remote. Token home is the one that's on the source chain, and token remote is the one on the target chain. So you need to build these smart contracts yourself, and by extending from the Smoot framework. And then another one is the apps. Apps here, yeah, app are the GUI component, okay, and then we have a couple of them already. So you have app, NFT market. You want to do an NFT quotient, you have an app there for that already. And you have app for ERC 3643, and I just show the GUI to you, and you can just leverage that and then just do it that way. Yeah, and then there are some code here as well. Yeah. And then agent, other things are the kind of follow layers, and you can contribute to those as well. Yeah, and then I want to show you the blockchain bridge for ERC 3643 token. And I just show you in the GitHub that you have token contract, right? So you can, here you can see that there's some token contract here, and then there's my token 3643, and then token home and token remote. So what can be done is very easy. When you want to extend from Smoot framework, what you need to do is that you create your source token, and in that source token, you just need to extend it from the WMB app. This is the messaging Solidity smart contract, and in this Solidity program, it also import other smart contracts that implement the EA specification. So these are all done already. What you need to do is just to import these libraries to your smart contract. And in your smart contract, you just need to implement a couple of things. Okay, meaning that when you receive a request to do cross-chain transaction, what you want to do. Okay, of course, these are the initialization, configuration, and then the send. Okay, send this. How do I going to send those transactions? And then you want to do the outbound call, because when you receive a request, you want to call the smart contract on the target chain to execute on the remote chain. So you need to have an outbound call and specifying the remote chain you want to call, and then specify the remote smart contract, specify the remote chain, specify the remote contract, and then send in the data to the remote chain. So this is the call that allows you to do the cross-chain function call, which is easy. Just tell the function call, the target chain you want to execute the smart contract, and then the smart contract address, and then the data you want to execute. Then everything, of course, you want to pay the fee as well. And then everything else is done behind the scene by Smoot framework. So this is sending that thing. So your application, the application you write should include an outbound function call to the remote chain. And then you specify those things. And then you also need to implement a function called receive. Okay, that means that because you are a smart contract, you want to call out, you also want the other chain to call you back. So you need to implement if somebody send you something, call you something, what are you going to process that call? So in this case here, it's just that it made a call. If somebody send you something, you do a transfer token in this case, which means mint, and then you emit an event here. So these are things that you want to do in your application. So for cross-chain token transfer is very easy. If you want to transfer a token from source chain to target chain, you just lock the token and then call the other side. And then if you want to redeem it, you just wait for the other side to unlock, and then redeem the original locked one, unlock the one that you locked. So this is a way to implement it. So this, you only take, I look at the code, it's only, what you need to add is only like 50 to 100 lines of code. So it's very, very easy, very easy. Yeah, and then you can, let's see, let me show, yeah, you can compile as well, yeah. Yeah, it's compiled. So all these codes are compilable, it's functioning well. So it's very good actually. Okay, so I show you the Smoot bridge. I also show you the compilation here, just for the smart contract. And then there's also several applications repository, application directories over there. You can compile those applications as well. Easily done. Yeah, let me go back to here. Yeah, and let me. Yeah, so I show you the bridge and also show you the remix compilation of those bridge token smart contract. Yeah, and then how can you contribute? How can you leverage this Smoot project? Okay, so we are still looking for contributors who can help us work on the technical steering committee, and also we want to partner with other bridge solutions. In fact, we are having kind of seminar together with Layer 0 and then Cacti team as well. And then we want help with enhancing the contributions. And also you can be a early adopter to support Smoot as well, because you saw the code already, you saw the demo, and it's expandable. And if you want to build on top of Smoot, you're welcome to help. And then we also kind of want some maintenance people to help improve the Smoot project overall. Because going from open source to enterprise level project, the code is quite a long way. We want some help on that as well. Yeah, and there are some information here that can be leveraged. Okay, it's first we have a kind of a post that describe with all the information of Discord link, GitHub link, meeting information, etc. You can look at this link and get all the information from there. And also, this project is based on the EEA specification, and this is the location for the EEA interoperability specification. So you can also get information from there as well. So I'm going to leave some time for questions. Yeah, I think there's a question linked to the GitHub repo kindly. Yeah, I think if you look at this document, it's there. It's there. I can also send it here as well. I have a question saying that it's a typo here. Daniel, link. I think it means a link to the GitHub repo. So I can send it from here as well. Yeah. Any questions, please? Do we have any questions? Oh, yeah. Oh, thank you, Mary Liz. I tried to copy the link and now you sent it. Okay, that's good. Yeah, well, yeah, I think this is a work that I think is very promising and useful. And I think the code that we have been checking hundreds of code, hundreds of files into the system is still very dynamic. It's changing on weekly basis. And if you have talent, you have passion to help building an open source interoperability project, you're very, very welcome to contact us. And just my name is Weijia Zhang. I'm VP of Engineering at OneChain, and the co-host today is Mary Liz. She works for Adora, and feel free to contact us as well if you have any suggestions. Yeah. Okay, thank you very much, and we'll close this call. Mendes, do you have anything else to say?
No, just that there's many years of the design and theory that went into finally coming to implementation here. So this is solid in theory. It just needs to be implemented, yeah, correctly.
Yeah. Well, I actually I see Daniel sent a question. We talk a lot. I did not talk about it here. It's about the question about Web4, where you can have AI agents in here, and since interoperability is currently a bottleneck, okay, where different AIs from yeah. There, yeah. The good question. We have been thinking about talking about AI. Actually, there are AI things that can be used here as well. And one of these things are like we want interoperability to be invisible to the users. Today, when you say cross-chain, you need to specify from Ethereum to Polygon. Normally, users want to transfer assets because there are better things to do in other blockchains. What you need to do is that I want to get the best yield from another blockchain. So users do not need to specify which chain they want to go to. They just want to say that I want to go to a lending platform that has the best yield. And the AI should be there to look at for different blockchains, look at for lending platforms in different blockchains, and choose the one that's optimized and give that to the user. So interoperability should be behind the scene. What needs to be done is to have AI agents that look at different blockchains altogether and then implement it or integrate it with interoperability so that AI agent can transfer these assets from one blockchain to another blockchain and have the best yield. But we have been exploring that, and the challenge is that first you need to kind of empower those AI agents. Okay, today, first to empower those AI agents. Second is to trust these AI agents, because you don't want these AI agents to manage your fund. And we had some breakthrough actually on that, because you can empower AI agent without giving them the authority to kind of directly handle your fund. So it could be that the fund is locked by smart contracts, but you give the messaging to the AI agents so that you give the instruction for them to move the fund, but without the authority to abuse the fund. So these are things we have been talking about. Okay, so yeah, well, thank you, Daniel. Yeah, you are certified the dev in Hedera. That's good. That's good. Well, thank you. Yeah, Toby, you have a good question. I have been in this field for 8 years. Okay, you want to be a pro in several months. Okay, good for you. Okay, if you need any help, let me know. I wrote a book about smart contract programming, a 450 pages book. If that will help you, you can read that book as well. Yeah, but it took me 7 years to fully understand this space actually. Manlius is smarter. She's only took a couple
No,
years.
it's like become a pro. Go do somebody who uses it for real, that solves real problems in this space. You'll learn the fastest.
Yeah. If this is a real project, you can join this project and come up with some ideas, yeah, and write the code. Yeah. Oh, go to why the book? Yeah, it's in Amazon. If you look at maybe can you look at that widgets and smart contract programming? Somebody asking about that book. Okay, let me check it quickly here.
Do you mean the blockchain and Ethereum smart contract solution development?
Yeah. Can you send that? Do me a favor,
Yeah.
send that link. Yeah. I don't even know the address. Always sometimes I forgot the book's name. I just search for it. Yeah, that is a textbook, actually.
That is it?
Did you send it?
Yes, yes, I did.
Oh, I did not see it updated yet.
In the messages. Do you not see it?
Oh, I was sending in chat. I was thinking about the chat. Okay, I have it now. I have it. I sent it through the chat. Yeah. Oh, yeah, yeah. I see it now. Oh, it took a while to go through.
It doesn't scroll. Zoom gives me nonsense as well.
Okay, okay. Yeah, yeah, I think yeah, this we make great progress, and interoperability is here to stay, okay? And Daniel make a good point that we need to have AI there as well. And yeah, definitely when you look at interoperability, it's about connecting blockchains, right? This is similar to like internet connecting PCs. You need to have interoperability for sure. Yeah. So I welcome anyone who participate in this meetup. I welcome you to kind of spend more time and look at this Smoot project and contribute to it. And if you have any questions, please feel free. We are very collaborative, and yeah, we work together. Okay. So yeah, just let us know if you need any help. If you can contribute. Yeah. So I think we can close this call now if there are no more other questions. Well, thank you again for joining this call, and we are very happy to give this presentation to you.